Hello class. Today what we are going to look at is angle relationships in circles. So this is talking about how do different angles, measures affect each other? How do they work together? So first one, tangent and intersected chord theorem. What this says is if a tangent and a chord intersect at a point on a circle, then the measure of each angle formed is 1/2 of the measure of its intercepted arc. So what does this mean? This means, see, we've got two angles here, right? Angle 1 and angle 2. Angle 1 is half the measure of this arc that it's intercepted. Angle 2 is half the measure of this arc that it's intercepted. And really, this is nothing more than what we saw last time, where we saw that if you have an inscribed angle, the inscribed angle is half the measure of the intercepted arc. Same thing. It's just that that other piece of the angle just happens to be outside the circle. It's tangent. But it's the same thing. You have an angle intercepting the arc, it's half. This is basically really nothing more than an inscribed angle. So it's half the measure of the arc. Okay, next one we have angles inside the circle theorem. If you have two chords that intersect inside a circle, I'm going to underline that because that is important. Inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs of the intercepted angle and its vertical angle. Okay, so we have angle 1 here, right? AC, DC both intersect inside the circle. So angle 1 is half the measure of arc DC plus arc AB. Angle 2 is half the measure of arc BC and arc AD. Okay, so the angle, the side that it's facing, right, that arc that it's facing, and the one behind it, the one on the vertical angle to it, you take those and you average them up, basically. Add those two up, divide by 2, that's the measure of this arc. Add these two up, divide by 2, that's the measure of that angle. All right? Not too bad. Next, angles outside the circle theorem. So same thing, only this time we are outside. If a tangent and a secant, or two tangents or two secants, intersect outside the circle, okay, outside the circle, then the measure of the angle formed is 1/2 the difference of the measures of the intercepted arcs. So it doesn't matter if you have two lines that intersect outside the circle, okay, and you either have tangents or secants or some combination thereof, right? They intersect the circle, they touch the circle or go through the circle, then the measure of this angle is going to be equal to the larger arc minus the smaller arc times 1/2, or divided by 2. And you will always have a larger arc and a smaller arc, and then divide by 2. Larger arc minus the smaller arc times 1/2, or divide by 2. Either way. All right? You're always going to have these two arcs. You're always going to subtract the larger minus the smaller, and then times 1/2, divide by 2. All right. Next one, the circumscribed angle theorem. This one is a little odd. It's okay. We're going to do some weird stuff to it, but the theorem itself is actually pretty simple. The measure of a circumscribed angle. Okay, a circumscribed means it's drawn around the circle, right? So here we have an angle that just touches the circle. It's tangent to the circle, and so this is a circumscribed angle. It's drawn around the circle. The measure of the circumscribed angle, angle D, is equal to 180 minus the measure of the central angle that intercepts the same arc. Okay, so we see angle D is tangent at A and B. So angle C here is the central angle that intercepts arc AB. And this is always going to be a minor arc every time. All right. So angle D is 180 minus the measure of angle C. Okay, minus the measure of that central angle. So that's pretty simple. It can be a little weird doing things with it, but it's pretty useful. So let's take a look at these. Do a couple examples real quick. I've got the wrong one. Where's my other one? Here we go. Let's actually work some of these out. And the wrong paper. That's okay. Here we go. It's going to make more sense if we actually work them out. Don't just see answers. All right. So we are told that line M is tangent to the circle, and we want to find the measure of the bolded arc or the bolded angle. Either way. So number one, A. Now, we're looking at angle 1 right here. This angle. We want to find the measure of that. Now we know that the arc that it intercepts, arc AB, is 130 degrees. Well, as we see over here, tangent and intersected chord theorem, the angle is 1/2 of its intercepted arc. So, the measure of angle 1 is equal to 1/2 of 130. So, the measure of angle 1 equals 130 divided by 2 is 65 degrees. All right, easy peasy. Okay, next one. Here we're looking for the measure of arc KJL. All right, this bolded arc right here. This is quite clearly a major arc, so the answer is going to be more than 180. Well, what we know is that the measure of angle JK, well, whatever this angle is, can't really name it there, but the measure of this angle is 125 degrees, which is half the intercepted arc. So the measure of arc, not J, arc KJL is equal to 2 times 125. Goes the other way around. And then the phone will ring. Lovely. So, 2 times 125. And the measure of arc KJL equals 250 degrees. And as you see, it is a major arc, just like we thought it would be. All right, so let's take a look down here. We want to do these. What I would like for you to do is pause the video, work these 3 out on your own, then come back and see how you did. All right, let's check your work. We need the measure of angle 1. Well, we see that angle 1 intercepts this 210 degree arc, right? So the measure of angle 1 is equal to 1/2 of 210. The measure of angle 1 equals, that would be 105 degrees. Just dividing by 2, that's it. Okay, here we're going the other way around, and what we have, 98, the angle equals 1/2, a little bit better way to do this, times the measure of arc TSR, right? So we multiply both sides by 2 to get rid of this 1/2, and we have that the measure of arc TSR equals, what is that, 18, so 196 degrees. All right, last one. We need the measure of arc XY. Notice it's just XY, so we're going to the minor arc there. And we're going to do basically the same thing we did right here, right? So 80 equals 1/2 the measure of XY, arc XY, multiply both sides by 2, and the measure of arc XY equals 160 degrees. There it is. Easy peasy. All right, let's take a look at example 2. Example 2. Find the value of x. So here we are looking at those angles where inside the circle and angles outside the circle, right? So if you remember, the angles inside the circle, right? If angles inside the circle, they are 1/2 the sum of the intercepted arcs, all right? So 1/2 the sum of the intercepted arcs. So x is equal to 1/2 times 130 plus, it's the sum, 156. All right? I'm being lazy, so I'm going to type it in my calculator. 1/2 times 30? 130 plus 156, which is 143. So x is equal to 143 degrees. That's hideous. There it is. Now, if the angle is outside the circle, instead of adding, we subtract. So x equals 1/2 times larger number minus the smaller number, 178 minus 76. So I'll pull over my handy dandy calculator. 1/2 times 178 minus 76 is 51. So x equals 51. Not too bad. All right. So here we go. I want you to look at number 4 and number 5. Work these, pause the video, work these out, then come back, see how you did. All right, let's see. Okay, so this is a little trickier. Here, we need to find the measure of the arc, not looking for the measure of the angle, right? Well, we know the measure of the angle is equal to 1/2 the two arcs added up because they intersect on the inside, right? But we don't even know what the measure of the angle is. But we can find it. This is a straight line, which means these two angles are supplementary. You've got a linear pair, right? So 180 minus 102 equals 78. So this angle right here is 78 degrees. Okay? And the angle, 78, is equal to 1/2 times 95 plus y. And now we're going to solve this for y. So first, we want to get rid of the 1/2. We are not going to distribute it in. I know a lot of you want to, but we're not going to. Instead, we're going to multiply it out. To get rid of 1/2, we're going to multiply by 2. All right, so let me just draw that on there so we can see this. Times 2 times 2. All right, so 2 times 78 is 156, I believe, right? 78. Yeah, 156. So 156 equals 95 plus y. Subtract 95 from both sides of the equation, and 61 equals y. There it is. Okay. Number 5, we have an angle outside. We are already given the angle. We're asked to find the measure of the arc. So we're just going to plug this into the equation that we have, right? The angle, 30 degrees, is equal to 1/2 times the difference of the two intercepted arcs. So A minus 44. Again, we want to get rid of that 1/2, so we are going to multiply by 2 on both sides of the equation. 60 equals A minus 44. We want to get A by itself, so we add 44 to both sides, and 104 equals A. All right? All right. Now, what we're going to look at, example 3. Find the value of x. Well, let's see here. We have two tangent lines intersecting the arc, and we want this. So let's look at our thing. What did we have about that? Because we don't have both of these. We could actually do this the same way we did number 5. Find this angle here, or this arc minus that arc, divide by 2, right? That is one thing we could do right here, angle outside the circle theorem. However, what we're going to do is the circumscribed angle theorem. Okay? So, the measure of the angle is equal to 180 minus the minor arc that it intercepts, right? Which we know from the central angle there. So we know the central angle, which means this arc is 135 degrees, right? And what we're going to do for that angle is very simply 180 minus 135, which equals 45, equals x. That was easy enough, right? No big deal. This is where it gets a little bit odd. All right, we want to find x. X is not the central angle, so we can't just subtract from 180 and be done with it, right? However, we are going to use that. So I'm going to go ahead and draw the central angle in here. We have angle EGF, right? Well, what we have, 30 degrees equals 180 minus the measure of angle G, right? So what we're going to do, 180 minus 30, and the measure of angle G is equal to 150 degrees. Okay, so this is 150, which means this arc is also going to be 150 degrees. X is an inscribed angle. From the last video, we know that the inscribed angle is 1/2 of its intercepted arc. So x is equal to 1/2 of 150. And x is equal to 75. All right. So that one is a little bit odd, but it's okay. It's still not too bad. Not too bad. Okay. So I want you to use this and pause the video, work out number 6 and number 7. All right. You're back. Let's see how you did. Number 6, very simple. We're going to use the circumscribed angle theorem, and we have the central angle. So x is just equal to 180 minus 120. X equals 60. There we go. We like that one. That one's easy. 7. Okay, again, we have that that inscribed angle like we did on problem example B. So I'm going to draw in the central angle that I'm going to use. All right. This is 50, so the measure of angle R is equal to 180 minus 50. So the measure of angle R equals 130 degrees. So that's R, 130, which means this arc right here is also 130 because that's a central angle. And now we're going to take care of that inscribed angle PTQ. And so x is going to equal 1/2 of 130. And so x equals 65. And there it is. All right, so that one is a little weird, this last little bit there, but for the most part, not bad. The important thing to remember, all right, if you have a tangent and an intercepted chord, it's just like having an inscribed angle. It's 1/2 of the arc. Easy. All right, circumscribed angle, central angle subtracted from 180. Again, easy. Not much to mess up there. Here's what people mess up. You got to remember, if the angles intersect, lines intersect inside the circle, you're going to take 1/2 of the sum. You add them up, divide by 2. If they intersect outside the circle, you take 1/2 of the difference, subtract them, and divide by 2. All right? Hopefully that helped. I'll see you next video.